In this video, we will learn how to derive the fiscal policy multiplier, and we will also solve a numerical question. The question is, the following data is given for an economy, that is the consumption function is being given as C is equal to 60 plus 0.75 y subscript d. Y d denotes the disposable income. Lump sum tax is being given as 100. Investment is equal to 80 minus 10 times I denotes the rate of interest, and government expenditure is autonomous here, which is 100. Demand for money is being denoted by L, which is equal to 0.2y minus 5I. Real money supply is being denoted by M bar upon P, which is equal to 65. We have to find out the value of fiscal policy multiplier. Okay, so before we solve for the fiscal policy multiplier, we will in fact derive the fiscal policy multiplier formula. Okay, then we will solve this question accordingly. Now, to find out the fiscal policy multiplier, okay, what will we do? First, we need two things. That is, we need to find out the IS equation and LM equation, and then we can solve for the fiscal policy multiplier. Okay, let's go first to the IS equation. Okay, so what does IS equation tell us? It shows us the goods market equilibrium, and goods market is in equilibrium when our total income is equal to the consumption expenditure plus investment expenditure plus government spending. Okay, and we know that, let me write it here, consumption is equal to A plus B Y subscript D. A denotes the autonomous consumption, that does not depend upon the level of income. B denotes the marginal propensity to consume, and Y subscript D denotes the disposable income. This is our consumption function. Similarly, what is the investment function? We know in this case investment is equal to I naught minus, let us denote DI. That is, investment is a negative function of rate of interest, and I naught denotes the autonomous investment that does not depend upon the level of rate of interest rather. So in place of I, can I write I naught minus D times I, plus we assume the government expenditure is autonomous, let's denote it by G naught. So Y will be equal to A plus B, and let me use another marker. So Y subscript D is the disposable income, and it is equal to the total income minus the taxes. We assume here the taxes are autonomous, which are in fact in this numerical also. So plus we have the autonomous investment minus D times I plus G naught. Okay, solving this further, so we have Y is equal to A plus by minus bt plus I naught minus d times I plus G naught. Transposing this y term to LHS, it will become y minus by is equal to a minus bt plus I naught, and let us first write this G naught term, and then we write this minus di. Okay, now next we take y common here, so we are left with 1 minus b, which will be equal to, here you can see a is the autonomous term, b is the marginal propensity to consume, which is constant here, t is the lump sum tax, which does not depend upon the level of income here. I naught is autonomous, G naught is autonomous. So can I write in these places, let us denote it by A. So can I write it as A minus DI. Okay, so we have this variable here, rate of interest, and because this varies here, so we have y. If we divide both sides by 1 upon b, what will we get? Dividing both sides by 1 upon b, and let's divide it here, dividing by 1 minus b. Here we also divide by 1 minus b, and here also we divide by 1 minus b. Okay, so here this stuff gets cancelled, and let us define here, let us denote 1 minus b by, okay, so let us denote 1 upon 1 minus b by some term. Let's denote it by w. And what is 1 upon 1 minus b? It is our Keynesian multiplier. Okay, 1 minus b is actually marginal propensity to save. So can I write this function as y is equal to, so we have a, and 1 upon 1 minus b we have denoted it by w, minus we have here di, and we have 1 upon 1 minus b as w. Okay, this will be our IS equation. And by the way, what does the IS equation tell us? It shows us different combinations of rate of interest and level of income where our goods market is in equilibrium. Okay, and in this case a times w denotes the intercept and d denotes the slope of the IS equation. Okay, similarly we need to find out the LM equation, that is the money market equilibrium. So when does money market equilibrium happen? And let me write it here. So then we need to find out the LM equation. LM equation shows us, or LM curve shows us the money market equilibrium. And money market is in equilibrium when demand for money is equal to the supply for money. Okay, and we also know that demand for money has two components, and if I write demand for money as k times y minus h times I is equal to money supply. Okay, and let's denote it by real money supply, which is in this case, m bar upon p, m bar upon p. Okay, this is the real money supply, which is fixed by the central authority in this case, which obviously is the exogenous variable here. Now what does this k tell us? K shows us the income sensitivity, rather let me express myself again. This k shows us the income sensitivity of demand for money, and let me write it here. It denotes income sensitivity, SENSITIVI, sensitivity of demand for money, and this H denotes the interest sensitivity of demand for money. Okay, interest sensitivity of demand for money, Okay, we say that money market is in equilibrium when demand for money is equal to supply of money. Demand for money has two components, that is the what we call the transactionary demand for money and the speculative demand for money. That is when demand for money is the positive function of the level of income and negative function of the level of rate of interest. Okay, and in this case we can write also L denotes the demand for money, which is equal to k times y minus h times I. That means demand for money increases as the income increases, and demand for money decreases as the rate of interest increases. Okay, so demand for money is the positive function of income because the coefficient of income is positive, and demand for money is negative function of the rate of interest because the coefficient of interest is here negative, which is h here. Okay, now let us solve this equation for interest rate. Can I write it in this fashion? H times I is equal to, if I transpose it here, so we will get k times y. Transposing this here, it becomes m bar upon p. Okay. Now dividing both sides by h, so if I divide by h here, and here also we divide by h, so can we get I is equal to h and h gets cancelled, we get here k upon h times y minus 1 upon h times m bar upon p. Okay, this is our LM equation, and LM equation shows us, okay, let me draw the small graphs of IS and LM equations here also. So let us say this is level of income, rate of interest. Okay, IS equation slopes downwards here, you can see, because there is negative relationship between the level of GDP and rate of interest, because the coefficient of I is here negative. And let me see if I have done it correctly or not. Okay, I have transposed this term here. Okay, so let me see if I have done some mistake in calculating this stuff. There is negative relationship between income and rate of interest. And what has happened here, if I transpose this term here, so it became positive. Okay, it is perfectly all right. This is the positive sloping function, rather this is the positive sloping curve. Its intercept can be negative because we have minus 1 upon h m upon p. Here we have to trace out the relationship between the rate of interest and level of income, and it is positive here because the coefficient of y is positive. So can I draw it like this? Let me draw the LM equation like this. This is the IS equation. Okay, now money market, rather, and the ISLM, what we call, we get the simultaneous equilibrium when IS is equal to LM. That means we plug the value of rate of interest in this IS equation. So can I write it in this fashion? Y is equal to A times W minus, we have D, let me write first W, then W, then we have I. The value of I is this very stuff, that is K upon H times Y minus 1 upon H times M upon P. Okay, solving further, we will get Y is equal to A times W minus D W, so let's write it here as K upon H times dW times Y, then minus into minus is plus, we get 1 upon H times dW times M upon P. Okay, now let us transpose this Y term to LHS, so we will get Y, here it is minus, it will become plus K upon H, then we have dW Y, and we are left with AW plus 1 upon H times dW times M upon P. Okay, let's take Y common here. If we take Y common, we are left with 1 plus K upon H times dW is equal to AW. And remember, W is our Keynesian multiplier, A is the autonomous things which we have denoted by A. Then we have plus 1 upon H times dW times M upon P, which denotes the real money supply. Now let's divide both sides by this term. So dividing by this term here. So dividing both sides by this very term. So what will happen here? 1 plus K upon H times dW, and here also we divide by this term is being divided by 1 plus K upon H times dW, and this term also by 1 plus K upon H times dW. Okay, so this step gets cancelled. So what we are left with? We are left with, and let me see if I have the space here, Y is equal to AW divided by 1 plus K upon H times dW plus this term, that is 1 upon H times dW times M dash upon P whole divided by this 1 plus K upon H times dW. Okay, since we have to find out the fiscal policy multiplier, so fiscal policy multiplier tells us, or the fiscal policy multiplier, we write it as, fiscal policy multiplier shows us the change in the income due to the change in the exogenous variables, in this case the government expenditure. Okay, and it is equal to, when we differentiate this function with respect to G, now you will be wondering where is G. Here you can see A is equal to A minus BT plus I naught plus G naught. So here in place of A we have G also. Okay, can I write in this place, or can I write in place of A as G? Okay, that means if A is equal to G, in this case the derivative of this function with respect to G, we will get only W in the first term, W divided by 1 plus K upon H times dW. Okay, since no G is involved in the second term, its derivative will be equal to 0. Now this second, if I take the derivative, and let me also explain it here, if I take the derivative of this function with respect to real money supply, that means the derivative, the change in the income due to the change in the real money supply. Okay, I will get the monetary policy multiplier, which will be equal to 1 upon H times dW divided by 1 plus K upon H times dW. Okay, since we are only interested in finding out the fiscal policy multiplier, so this will be the formula. Okay, now what are the meanings of different terms here? W is equal to 1 divided by 1 minus B, which is equal to, in this case, in this question, it is equal to 1 divided by 1 minus, what is B? Marginal propensity to consume, which is equal to 0.75, which is equal to 1 divided by 0.25. So we will get the value of 1 upon 0.25. So the value of W we got is 4. What about K? What is K and H, D and W? Now if you see it clearly, K denotes the income sensitivity of demand for money. For this we have this very equation. Rather, okay, here we have, and let me write it here. L is equal to 0.2y minus 5 times I. So the value of K is this. Okay, K is the income sensitivity of demand for money, which is K here, and this minus 5 denotes the interest sensitivity of demand for money, which is our H. Okay, so we are done with K and H. What about D? D is minus 10 because investment is the negative function of the rate of interest, which is the coefficient of I is here minus 10. That means this denotes our D here. Okay, marginal propensity to invest, what we call this D here. Then what will be our fiscal policy multiplier? That is the change in the income due to the change in the government spending, which is equal to, so W we got is 4 divided by, we have 1 plus the value of K. K is 0.2, okay, 0.2 times D. What is D? D is minus 10. Okay, no, yet be minus 10. Then what is W? W we calculated as 4 divided by H. The value of H is minus 5 here. Okay, minus 5. So our fiscal policy multiplier will be equal to, we have 4 divided by, let us cancel this minus and minus here. Okay, we are left with 1 plus 0.2 goes bata the, agar aap multiply karo 10 to 10 gets cancelled, so we will be left with 2 4s are 8 divided by 5, which will be equal to 4 divided by 8 divided by 5. Okay, so 8 divided by 5, we have 1 plus, okay, let's do the multiplication. 5 ones are 5, 5 8, now the ka batrua, so 13 divided by 5, 13 divided by 5, which will be equal to 4 divided by 1 into 5 divided by 13, so which is equal to 4 5s are 20. Let me see if I am within my limits. Okay, I am. So we got fiscal policy multiplier is equal to wo divided by, that is 20 divided by trua, which is equal to, so we have 20, we have 13, 13 ones are 13, ये तो वालोस वहाँ नहीं तो वात आइथुले ऐसे 7, ये तो खालो point, ये तो खालो 0, 13 त्रुआ गई शतु गई नॉर लोग शतु गई 52 दागे 2 3 5, so 13 5s are 65. Then we are okay, so we got 1.5, then 70 minus 65, we will get 70 minus 65, we will get 5, then we put 0, so 13 okay, 13 3s are, we will get 13 3s are. Now let me do it again. Let me see if I have corner left to do this calculation. So 20 divided by 13, you can calculate it as, or rather let me calculate it here. So we have 13 ones are 13, I think ऐसे 7, ये तो point, ये तो 0, 13 5s are 65, 5 3s are 15, 5 1s are 5, okay, 65. Then we get 5 0, 13 3s are 39. Okay, we get 1.53. So the fiscal policy multiplier in this case will be 1.53. Okay, I hope I make myself clear in this video. So I make these videos for free. I don't charge any penny for these. Okay, I don't take any online classes or all other stuff. I'm just doing it for you people. Okay, if you like these series, please share, subscribe, and also like. That is the only motivation for me to keep going on. Okay, you will not find this kind of detailed explanation free of cost at any channel. Okay, so I hope I make myself clear. Thank you.